Equals 5x cubed plus x. That's what's causing you the most angst.
Yes.
So then you would say the derivative would therefore be equal to derivative with respect to u of u to the 1/2 power times the derivative with respect to x of 5x cubed plus x. So that's 1/2 u to the negative 1/2 times 15x squared plus 1. Am I wrong? Feeling good. 1/2, what's u? 5x to the third plus x to the negative 1/2 power times 15x squared plus 1. Ain't nothing going to be nicer about that, so we're just going to leave it just like that. What are you going to do with that? You put the square root at the bottom and square both sides, conjugate pair. You can do that. Take a while. It'll look almost as ugly as when you started. Fair enough?
Yeah.
That negative square root bar, because that's underneath. There's no multiplying that in. How would you multiply that in? You'd have to do a conjugate pair on the bottom, and then you have to put it up to the top, and then you're multiplying through by a square root bar, which would just make the whole thing uglier to begin with. So that's really not going to buy you anything. So we leave that alone. Yeah, we leave that alone. Okay. So what started this conversation? What was the first thing we noticed way back when we were looking at these problems oh so long ago, and we first said we want a Cleary rule? What was the Cleary rule? We were missing a 3. The 3 is just the derivative of the inside, right? I mean, when we set u equal to the inside, we basically are taking the derivative of the outside using the Cleary rule, right? And then all we needed was the 3, which is the derivative of the outside. This is called the inners-outers approach, which is take the derivative like Cleary wants you to do. Now, if you don't see that, you have to do the u rule. But if you see it as you normally would, you just simply look and go, well, I'm going to take the derivative the way Cleary would do it. And at the end, I'm going to tack on the derivative of the inside. Explain the Cleary rule, and Cleary's not hearing me. That's what is scary. You have any idea what I'm talking about? So, using that idea, and again, you never have to use this idea. We can do this using u substitution all day long. Okay? Using this idea, we could recognize that this is really sine x to the 5th power. F of x is equal to it for number 5. Now, the way I would formally do this, I'd say u equals to the inside. And then I would do exactly what we've been doing all along, right? But if you remember, what started this was the idea, well, I'm going to take the derivative of 5th power things. It's just 5 sine x to the 4th power, is it not? Yeah. Except I have to tack on the what? The derivative of the inside, which would be what? There I am. I'm done. Inners outers. Okay? The other way is a formal way to write what we're doing. All we're really doing is we're saying take the derivative of the outside as if that thing wasn't wrong, and then take the derivative of the inside. If you get confused, though, where should you go? Set u equal to this, and just make sure you're being comfortable where you are, right? If you've got a chain, and you're trying to do it this way, and you don't see it like right away, don't do it this way. Your life will just become really hard. Eventually, all of you are going to do it this way, whether you like it or not. You do enough of these, you're like, oh, I just do it this way. Okay? But for a while, you can use u in addition to that. So using the next one. Everybody try the next one, see if we can make sense of this. All right, try number 6, the inners-outers rule. Yes, ma'am. What could you possibly not want to share with everybody? I just want to share with you. Okay, I'm really about to go aggro. Last year, I spent a little time with the whole sine to the 5th power is the same as this. These are the same thing. If you don't recognize this, you need to button that in your memory. That's the 4th person that said that to me, and that's something that we should know by now. That's not a little thing. That's a huge thing. Okay, move forward. Let's do 6. Here we go, 6. So using the inner-outer rule. Sorry, Mr. Cleary, you didn't make this up. What do? I swear this is just math students made this up. Like I just do this inner-outer thing. Doesn't sound like a normal mathematician thing. So I throw the 7 out in front. Drop its power by 1. Take the rid of the inside, which would be 4x. I'm done. Well, no, I'd probably have to write 1428x times 2x squared minus 1 to the 6th. Because usually those two can go together, right? Done. Could I do it with use of? Yes, I could do a use substitution all day long. Okay? You are not done with it because when you get scary, what are you going to do? Your fallback position is use this. Let's see what happens. If you look at a problem and you go, I'm not really clear, then back up and use the use substitution. Yes?
You can do, like, if I did this inner-outer rule on 3, I could do it.
You have to remember to chain, right? So if you see it, you can do it. That's always the rule. I mean, if the inner-outer thing, you look at it and you go, I get it, then this is lovely for you. Then you should do this. The only reason I introduced it so early is because somebody by now has already figured this out. It's already like, well, why don't I just do this? And it's like, okay, yes, but. So when you get uncomfortable, that's when I want you to go back. Okay, so first step is use the ugly part. Oh, I get what I'm doing, and move forward from there. Does that make sense?
And also on a chain, you can just do.
It's the whole outside times the whole inside derivative times the inside of the inside derivative.
Right. And you could do like.
You check in, check out with a vice principal. You walk in the door. You have to hand in your phone every morning. That'd be good. I'd like that. There's my 2. Watch out for that pi squared. A lot of people want to turn that into a variable. It's not, right? It's a number. So you don't go 2 pi. Derivative of pi squared is not 2 pi, it's 0. Right? Because pi is just a number. It's like 9-ish. You can, but it's pi squared, so that'd be the incorrect answer. I'm not stopping you, man.
Why do you have 2 pi or 7 pi? Oh,
it's 2.
Yeah.
2 pi. I'm off by ½ inch, so I just made it a whole lot worse.
Why is it to the 8?
It's not to the 8th, it's the 2nd. That's another one I tried to fix. Okay, my pin's up here. Let's see if I can pull this off. How's that? I just put it back in, right?
Yeah. Well, you have to, for number 1, would you have to use a rule?
Yeah. Do you know what the derivative of cosine 3x is?
No.
Okay, then you have to use a rule. That's not multiplication because you know 3x is inside the cosine because you learned that last year in trig, which is the primary reason why you teach trig before you teach calculus. Just so you know you can't do that. The temptation we always pull out the 3. No, no. That's one of those rules that was on the wall. You don't want that.
So it'd be negative 3 sine 3x.
Yep. Not too shabby, eh?